In this video here, we're going to be talking about how to solve a simple logarithmic equation, right? So there is a step-by-step process that you can use to solve logarithmic equations, but sometimes, for some logarithmic equations, there's a simpler method that you can use, which is what we'll look at in the example in this video, right? And what happens when you have one of these simpler types of logarithmic equations, or how you can identify when to use this simpler method, is if you have a log on one side of the equation and then another log on the other side of the equation, and they have the same bases, and then there's nothing else on either side of the equation, just a log equal to a log. That's when you can use this simpler method. If you have a log on one side equal to a number on the other side, then this method doesn't work, and I'm going to do another video where I talk about how to solve those more complicated types of logarithmic equations. But for a simpler type, like this one here, we'll go through the method to solve this simpler one right here. All right, so log of x squared plus 1 equals log of x minus 2 plus log of x plus 3. All right, so you might already think, well, you just said a log on one side equal to a log on the other side and nothing else, but this one actually has two logs on this side of the equation, right? And that's true, but this one, since we have two logs on this side of the equation, I can use the laws of logarithms to actually combine those together into a single log, and then I'll have one log on each side, and I'll be able to use this easier method. Right, so the first thing, anytime you're solving any type of logarithmic equation, if you have more than one logarithm in your equation, you want to combine them together, right? So on this side here, this log of x minus 2 plus the log of x plus 3, I have to go back to those laws of logarithms, which if you haven't watched the video that I did on the laws of logarithms, you should check them out. There's only 3 laws of logarithms, but in order to solve logarithmic equations, sometimes you have to pull out those laws of logs and actually use them to combine things together before you can solve the equation, which is what we have to do here, right? So log of x minus 2 plus log of x plus 3, when I have two logarithms that are being added together, if they have the same base, and both of these logs here, right, they don't have a number in the subscript, which means they're the common log, which means they're base 10, right? So both of these two logs are base 10, so they have the same base, which means I can apply this law of logarithms that says if I have the two logs with the same base that are added together, I add them together by combining them into a single log, keeping that same base, so it's still the common log with base 10, and multiplying these two things here, these arguments. So it's x minus 2 times x plus 3. Right, so the right side of the equation becomes just the log of x minus 2 times x plus 3. Right, that's the law of logarithms for adding two logs with the same base. Right, and once we do that, now we see it's what I described earlier. I have a log base 10, a common log on this side of the equation, equal to a log base 10 on this side of the equation, and there's nothing else on either side. All right, so in a case like this where you have one log on each side of the equation, the bases match, basically the logs will cancel each other out. Now what's happening here, you're not dividing log on both sides, that's not at all what's going on. But basically if the log of this equals the log of that, the stuff that's inside the parentheses or the brackets has to match up. And it's similar to, if you watch the video that I did about solving a simple exponential equation, it's the same reason as what we talked about in that video. Right? The logarithmic function is a one-to-one function, right? Meaning the graph hits each y value only one single time, right? So wherever my x and my y value are, whatever the output is for this side of the equation, if it's equal to the output for this side, well, this graph only hits that y value, that y value in one single place, which means the inputs have to be exactly the same. So if the log of this equals the log of that, this has to equal that, right? The logs don't matter at that point. Right? Again, we're not dividing log on both sides because that's not something that you're able to do. But it's almost like the logs at this point are irrelevant, and all that matters is that what's inside the logs, the x squared plus 1, is equal to the x minus 2 times the x plus 3. Right? And again, just like what we did the simple exponential equations when I had the same base on either side raised to a power, I ignored the bases, I just set the exponents equal to each other. I can do the same thing when I have logs. When the two sides have the same log of the same base, I ignore those logs, right? They don't technically cancel out. I just ignore them, and I set the arguments equal to each other. And then I solve this equation, which looks like it's going to be a quadratic equation because we have an x squared here, right? So once I kind of get rid of those logs, then I just use whatever algebra I need to use in order to solve whatever equation is left. So I got all this here. Let me multiply out the stuff on this side, this x minus 2 times x plus 3. And see what that gives us. So I have x squared plus 1 equal, and then if I FOIL this, I'm going to have an x squared, I'm going to have plus 3x minus 2x, so that's going to be plus 1x, or just plus x, and then I'm going to have minus 6. So I got x squared plus 1 equals x squared plus x minus 6. And now I go ahead and I solve for x, which in this case, if I want to bring all the, all the terms to the same side, since I have an x squared involved, but look what happens. If I subtract the x squared, it actually cancels out on both sides. Right? So since I have a 1x squared on both sides of the equation, it actually cancels out, and I end up with 1 equals x minus 6. And it turns out I don't actually have a quadratic equation. It turns into just a linear equation. So then to solve for x, I just add 6 to both sides, and I get x equals 7. All right, now, at this point back here, when we ignore the logs and we set those two equations equal to each other, sometimes that does turn into a quadratic equation. Right? Sometimes the x squareds won't cancel out, or you'll have an x squared on one side and not the other side, and then you would have to solve that like a quadratic equation. Right? So after those logs go away, it's just whatever algebra is necessary in order to solve it. Sometimes it's simple like this, it was just adding the 6 to the other side. Sometimes if it's quadratic, you have to use factoring or the quadratic formula in order to solve and get your solution to whatever equation you end up with. All right, so that's solving a simple type of logarithmic function where I have logs on each side of the equation, they both have the same base, I ignore the logarithms, and I set the two arguments equal to each other, and I just go ahead and solve from there. All right. So I'm going to make another video now where I talk about how to solve logarithmic equations that are not in this form. Like if I have a log of x squared plus 1 equal to, not another log, but like just a number on that side of the equation, well, what do I do to solve that equation? That's going to be a little bit more complicated as far as the steps you have to take to solve it. All right, so make sure you check out that next video I'm going to do where we talk about the step-by-step process to solve any type of logarithmic function, and we'll do some examples of those as well.